Hello. In this video we are going to look at the use of some lesser known circuit components in circuit diagrams. These are more advanced than the very simple circuit components you might have used when you initially start making circuits. So we've got an LED, which stands for light emitting diode, an LDR, which stands for light dependent resistor, a buzzer, a diode, a reed switch, a reed relay, and an SPDT switch. So we're going to work our way through these. Now the first one is called an LED. And, sorry, we're back. They went missing for a minute. So, these are LEDs. In fact, these aren't LEDs, these are LEDs which are attached on boards to a device called resistors. Now, the reason for that is this is the LED, and on its own, an LED has very, very little resistance. The problem is you connect it to anything and it lets a huge current through, it gets very hot, and it tends to go a bit cloudy, start smoking, smell a bit funny, but then it never works again. So you have to connect it to a resistor. So in the previous videos, we looked at how if you increase resistance, you reduce the current. And that's what this does. It reduces the current to a sensible level for the LED. You have to calculate the value of the resistor to get a sensible current. And I have checked that for using our cell here. Now, an LED is part of a component called a diode. And if I just get a diode, that is what a diode on its own looks like. And you can see the LED has the light emitting bits coming off it, whereas a diode doesn't. And the difference between them is just that. They're both diodes, but one emits light when you have current passing through it. What a diode does is, as you can see here, it only allows current to pass in one direction in the circuit. And we'll see that in action with the light emitting diode. Now, the arrow points in the direction the current needs to go, which is plus to minus. And what I'm going to do is initially, I'm going to connect it up wrong. So I'm going to connect it up from the wrong way, which is negative to positive. And what that means is the current is from the cell is trying to go this way, but the diode isn't allowing that through. So you can see the arrow on the diode, it's not letting it through. But if I swap the connections around, so I go plus to minus, then it still doesn't work. What that might mean is we don't have enough power in that cell. There we go. So, need a little bit more. And as I said, you've got to rate it right. So, here you've got your battery pack, you've got the diode going the right way, and just to show you it won't work in reverse, there you go. So diode going the wrong way doesn't work, only allows the current to go in one direction. Okay, and you must have this connection here. What I'm going to do next is add in the second diode into the circuit. Sorry, second light emitting diode into the circuit. What I'm doing is I'm creating a junction here. Those that are pretty good with circuits already, there's a slightly easier way you can wire this with less wires. Oops, that's a regular diode, but we're not too worried about that. So, what I've got there is my two LEDs connected, okay? And you see plus to minus, which means my arrows are pointing the right way, sorted, my LEDs are connected up properly. But if I turn one the other way, it won't light, but it doesn't affect the other LED, which is in a parallel branch. So the parallel branches do operate independently of each other, which means that one can operate even though this one isn't. What I can do though is if I turn the battery pack around, hopefully you'll know what's going to happen, is the other light will turn on because now that's connected, because you now got positive on this side running through to negative, which is on that side. Okay, and that is our LED circuits. Now, here's a thought experiment for you. If I had both of these running, if I connected something over here which increased the resistance in the circuit, what do you think would happen to the brightness of these two LEDs? You're right in that if you put a resistor in here, you would reduce the current in the circuit and you would reduce the brightness of the two LEDs. Okay, so that is LEDs, how they work, and I hope that makes sense. Now, what I'm going to do, I'm going to introduce another component here. And this component is called an SPDT switch. And this is what it looks like. And SPDT stands for single pole double throw. What that means is with the switch on this side, these two are connected, like it shows in the diagram. But if I flick the switch, and the diagram can't move, but that arm is just flicked over to this side, meaning these two are now connected together. So there's no option where nothing's connected. It's either this pole is connected to this throw or that one. That's the single pole double throw. So connected to there, connected to there. And I can connect that up with this circuit here, like this. So put it at this junction. And what that means is either that LED will be on, or I push this side, meaning that LED will be on, this side, that side. So it's our single pole double throw. So you've got the first throw and the second throw, and I can flick between those, and that's how that switch works. If I take another one and I put it onto the other side, just watch this. Now, if I do that, neither of the LEDs are on. So this side is down and this side is down. And what that means is this side is connected to this part of the circuit. This is connected to this part of the circuit. But that means that there isn't a connection all the way through. So what I can either do is leave that one there and flick this to that side, meaning this side is connected through to here, or I can flick that one to that side and that one to that side, meaning the current is now going from this side all the way through round to there. Now note, my black and my red wires are the wrong way around, and I've deliberately done that because I want to make the point it doesn't matter what colour the wires are. What matters is the side of the battery, the positive side here, and the arrows are pointing towards the negative, which is round here. The colours of the wire doesn't matter. It just helps see things, okay? But I trust that you can manage all this. So that's our SPDT switches and checking how things are connected, okay? So I connect both of those that way. So opposite sides, it doesn't work. Opposite sides, it doesn't work. Same sides, it's on. Same sides, it's on. Okay. And that is our SPDT switch. Now we're going to have a look at a component called a light dependent resistor. So I'm going to get rid of my SPDT switches. I'm going to get rid of that LED and I'm going to bring in my light dependent resistor. Now the way this works, this LDR changes its resistance depending on the amount of light going through it. And if I connect this up like that, we can observe this. So we've got this, we've got our LED. Now if I put my finger over this, the LED goes off. And as I slowly release it, it gets brighter, dimmer, brighter, dimmer, brighter. So my finger blocks the light, lets light through. So you should be able to draw a conclusion about this. If I reduce the light level, which reduces the brightness of the LED, what does that do to the current? Hopefully you've got that. So more light is less current, more light is less resistance, which means more current brighter LED. Less light, more resistance, dimmer LED. And that's how the LDR works. Its resistance depends on the light that falls on it. And it's not just on and off. So if I just cover the light a little bit, you can see it just dims a little bit and then comes back a little bit and back. Do the same. See if I cover that from the other light sources, it gets very dim, then brighter again. It's a very interesting component, very useful if you want a light sensor. Now, moving on through our components, our next one is called a reed switch. We'll swap the light dependent resistor out for that. Now, a reed switch, you can just about see it in there. You can see the symbol here. You've got, as it says, 2 reeds, and within the actual switch here, you can see 1 reed here and 1 reed there. Now, in the middle there, they're not actually connected. They're very close together, but not connected, as it shows in this diagram. Now, if I connect that, you can see the circuit is off. But if I take a magnet, and I'm going to turn this upside down so that I can point my magnet at it a bit more easily. Bring the magnet near. Whoop. What happens is the magnet causes the reeds, there we go, to be attracted together. Now, so it's not an overly strong magnet, so you just got to get it lined up right. And that means when the magnet's brought near, the reeds touch, light turns on, bring it away, they move away from each other, no longer connected. So when the magnet is brought near, the 2 reeds are like this, and when the magnet's brought near, they come together, and when the magnet is brought away, they disconnect. So without the magnet, it's an open switch, and with the magnet, it's a closed switch. Okay? And if you listen very carefully, you'll hear the little tick of the 2 sides coming together. Okay, hopefully you can hear that. So that is a reed switch, and it's kept in that glass case just to protect the reeds, so we don't kind of hit anything, so we don't hit them or knock them, because they're very carefully lined up. Okay, and that is all a reed switch is. So it's a switch that can be turned on with a magnet. But no, I don't actually have to touch the switch for it to turn on. Now, the next component I'm going to look at is something called a reed relay, and that has a reed switch in it, but also a coil of wire here. And the way this works is we're going to have what we call a low current circuit and a high current circuit. Now, our high current circuit is going to be on this side, and that's the big battery pack. That is going to be connected through a lamp, and that's going to go through the relay. Which is a reed switch on this side. The problem with this is it's all encased up, and actually often when you're dealing with reed switches, we don't have magnets nearby to turn them on. So what we're going to do in this circuit is, rather than using a magnet to turn on our switch, which you can still do if you want to, what we're going to do is use a battery. Now, if I take a little push switch here and I connect a cell up to this, what is on this side is a coil of wire, and what that becomes is an electromagnet. Now, the 2 sides of this circuit are not electrically connected. They're physically connected with some tape and a bit of kind of keeping them there in the middle, but electrically they are separated, and that means if anything goes wrong on this high current, high voltage side, it's not going to reach the person over here. So this is the low voltage activation circuit. So if I press this switch, the bulb comes on. But the bulb is coming on because this switch engages the electromagnet here, which causes the reeds within the switch to snap together, And that means that the current can get through, the bulb turns on. Okay, and what that means is if there is a problem with this side, something disastrous happens, I'm safe over here. My fingers aren't going to get a big electric shock. And that is the idea of this relay circuit. It's using a low voltage circuit to turn on a high voltage circuit. We don't want an actual electrical connection between the two. Okay, and if you listen really carefully, there's a little click coming out of the reed relay there as it turns on. Okay. Now the final component, which is everyone's favourite, is our buzzer. Now this is called an active buzzer, and what an active buzzer means is if you apply electricity or a battery across it, then it will turn on. A passive buzzer needs what's called a driver, and needs to go. So this one, you just apply power and it makes an annoying noise. And what I'm going to do is, this is a buzzer being turned on by a reed relay connection to make an annoying noise. Some would call it overkill, I call it good engineering. So, just a reminder about the reed relay circuit. What it means is, this circuit, that might be very powerful, we don't want to go near that, could be a really, really loud speaker, and the relay circuit over here turns that on, okay? And that is those components introduced. Thank you very much.